Assalamu alaikum and hello everyone. My name is Jamee and this is my presentation for the Real-Time System Virtual Symposium. My topic is investigative study into improved response time analysis techniques. So, my system, the real-time cotton crop disease detection system, communicates with a third-party API in real time to obtain all the necessary information to complete the diagnostic correctly. Therefore, the system must adhere to strict timing requirements, and to ensure that the system is schedulable, response time analysis calculation must be conducted. So, this research will at first suggest the parameters for response time analysis calculation, and then it will look through some past rules and use the best one to calculate response time analysis and also construct the timeline model. Lastly, it will research through some past papers and try to find an enhanced response time analysis calculation or algorithm that can improve the one that is currently present in the system. So the tasks that have been suggested is activate camera sensor, pre-process image, save image to phone storage, authenticate API key, retrieve results from API. So as rate monotonic approach is adapted, the priority of the process is inversely proportional to the period it will run for, and the task will be organized based on their priority, which is based on the period. And after that, the calculation is conducted by hand using this algorithm, and using the calculation, the worst case response times is calculated, and based on that, values for period, values for worst case execution time, and values for deadline can be suggested. The comparison of the tools, in short, the three tools have been compared: TimeStool, Cheddar, and PyCharm. All of these tools can be used for free. All of these tools support response time analysis calculation, but only TimeStool and Cheddar support modeling. All of these tools, only TimeStool and Cheddar has a easy to use UI, but the Times tool, the GUI in Times tool is much more refined and is much more easy to use. Times tool has existed for a much longer time and has received a lot of validation, bug fixes, and quality of life improvements, and is much easier to use. And more extensive documentation is present for Times tool relative to all other tools. So this research, and based on those, this research shows Times tool as it is more reliable, and it has received more recognition from past researches because of its easy to use user interface, its abundant documentation, and its intuitive simulations. This is the Times tool, and here all the tasks are inputted with their corresponding computational values, the deadlines, and the time periods, and the simulation is run, and this is the simulation model that is obtained. Here is a closer look. And after that, the worst case response times are also calculated here, and we can see the values for worst case response time here. So the problems, two papers were discussed before. First paper was discussed about offset based response time analysis of distributed systems. So here the earliest deadline first approach was used, and then an additional parameter offset was added. And the problem discussed was that distributed systems using fixed priority scheduling approaches can be difficult and inefficient, as each processing or communication resource must be considered independent. These strategies yield unfavorable outcomes due to the independent resource assumption. The solution discussed in the first paper was that in order to handle the difficult and efficient task of performing schedulability analysis on distributed systems, an offset-based enhanced schedulability analysis technique with earliest deadline first approach would be adapted. The second paper that was discussed was a response time analysis with limited carry in for global earliest deadline for scheduling. Global scheduling algorithms are very effective at scheduling multiprocessor systems. However, they are plagued with a problem. Schedulability analysis tests on multiprocessor global scheduling systems often yield results that are unreliable and unreproducible, and a task that is deemed not schedulable by one test may be shown to be schedulable by another one, which is a problem. And the solution discussed is, in order to improve the results of the schedulability analysis of global scheduling system and to yield reliable and reproducible results which could not be done before, the researchers have offered more accurate algorithms for computing the response time of global earliest deadline first scheduling real-time tasks. So here are the detailed comparison. Paper 1 has received a lot more astounding recognition and has over 108 citations relative to the 13 citations by paper 2. So this paper 1 highlights more experimentation calculation to help us to understand the calculations and to help us actually judge the integrated of the calculations. Paper 1 proposes an EDF policy earliest deadline first policy, while paper 2 proposes a global early deadline first policy, which is more suited for complex multiprocessor systems, while paper 1 is more suited for simpler systems. And only one single parameter has to be introduced in paper 1, which is offset, but multiple parameters have to be introduced to apply the solution from paper 2. So by choice, so based on the above this comparison, paper 1 was selected as it has more reliability, as it is more suited for simple systems, and as it provides a lot of testing calculations which can be used to test results, and it is also much more simple to implement as it only has one parameter that needs to be included, which is offset. And to implement the chosen solution, the new parameter offset must be statistically introduced, and the rate monotonic approach must be changed to the earliest deadline first approach. And this is the results that have been obtained for the enhanced method. This is the old calculation and this is the current calculation. It can be seen that for most of the tasks, the worst case response times have improved significantly. Here from 35, it has become 32, which is much less. From 65, it has become 52. From 20, it has become 15. So there is some improvements. So this is the old timeline model, and this is the timeline model for the improved solution. We can see that the tasks are being completed faster and there is more idle time. So before, rate monotonic approach was being used, but now the earliest deadline first approach is being used, and there are significant improvements in worst case response times, which has resulted in more idle times. In conclusion, though the response times for both of the tasks become slightly worse, the response times for other three tasks improve significantly. Now I will demo the times tool for response time analysis and for the modeling. For the initial system, before an enhancement was applied, this is the initial system where rate monotonic approach was used, and all the tasks have been inputted manually. And after that, first we'll run the simulation. Here we can see the simulation, and here we can see the tasks being performed. We'll pause the simulation, and right now we'll try to run the schedulability analysis. So we can see the values here. So this was for the system before the enhancement. So let's look at the system after the enhancement. So we'll have to close this, and after that we'll open the other system, the enhanced schedulability analysis system. So here it is using an earliest deadline first approach, and we can see the values have been inputted. And right now let's try running the simulation. And here we get the simulation for the enhanced system, and we can see that the idle times are different and the values are different. And here the scheduling process is also different. So this is it for the demo, and this is the enhanced system, and the enhanced system is performing better as it is having more idle time, and the worst case response time values are also becoming smaller. So that is it for my demo. Thank you very much for listening to me. Assalamu alaikum.